So, as you know, that today our topic is what? Introduction to machine learning. And myself, Dr. Dibya Bora, and I'm an assistant professor in the School of Computing Science, the Assam Kaziranga University. Well, so the agenda of this talk will be covering these topics. First, I will introduce what is machine learning. Then I'll talk about few things about the history of machine learning. Then machine learning life cycle. After that, I'll come to the different types of learning. Then finally, I'll conclude the talk by discussing some important applications of machine learning and by showing you two practicals. Well, then let's start. So, first of all, let's try to understand the concept of machine learning with an analogy. I hope all of you can see this picture. So, what is this actually? It's you trying to buy mango. Okay. So, how you choose the base mangoes? Might be you and me will have different choice, or I can say the different way of judging that this is a base mango or this is not a good mango, like that, isn't it? So observation might be like that. Bright yellow mangoes are sweeter, soft mangoes are juicier, green mangoes are tastier than yellow one. So these are the different observations that we can make through by experience for different purchasing experience from different purchasing experience with different mango sellers, isn't it? So in Assamese, we used to speak like that. Tenga aam ebar hai besibo pare. This means in Hindi that if ये कोई एक मैंगो कोई एक आम खट्टा है और उसको आपको मीठा बोल के एक ही बार बेच सकते हैं, isn't it? So same thing means sure mango can be sold only once. So this is very important that you should have experience about buying the mangoes, base mangoes. So, but every time when you make a new observation from your experiments, you have to modify the list of rules manually. This is the way we human do. Now, is it possible for the machine? And with that, this is where the machine learning comes into the picture. Okay. So I mean to say that what is machine learning from this example? In the real world, we are surrounded by humans who can learn everything from their experiences with their learning capabilities. And we have computers or machines which work on our instructions. But the question is that can a machine also learn from experiences or past data like a human does? So again, this is where the role of machine learning plays, come into play, isn't it? So look at this figure. This is you, human. I can learn everything automatically from experiences. Can you learn? Then machine responds like, yes, I can also learn from the past data with the help of machine. Now, from this example and from this scenario, I hope that all of you got what is machine learning, isn't it? So the machine learning is the way to teach machine to predict something new from the old or past experiences or past data. Clear? So that's how we can understand the meaning of machine learning. Now let's come to the textual based definition. So machine learning can be said as a subset of artificial intelligence that is mainly concerned with the development of algorithms which allow a computer to learn from the data and past experiences on their own. So, from these definitions, what you have got? First point you have got that this machine learning is a subset of artificial intelligence. And I hope that you have already attended my talk on artificial intelligence in the last session. There, I have explained everything or important topics related to AI. So we just got that this machine learning is just a subset of AI. And it mainly concerned with the development of algorithms. So algorithm plays the vital role here. And these algorithms allow the computer to learn from the data and the past experiences on their own. Now, this term, machine learning, who introduced it? It's introduced by Arthur Samuel in 1959. And as per or according to him, machine learning enables a machine to automatically learn from data, improve performance from experiences, and predict things without being explicitly programmed. Clear? So Arthur Samuel can be considered as the father of machine learning. I hope you also know who is the father of artificial intelligence. If you know, you can type your answer through the chat option. Okay. So he is Arthur Samuel, and he said that machine learning, the field of study that gives computers the ability to learn without being explicitly programmed. Clear? So, one more definition from Tom Mitchell. He's computer scientist and the author of the famous book Machine Learning. This is the cover of the book. Okay. So, as per Tom Mitchell, a computer program is said to learn from experience E with some class of task T and a performance measure if its performance at task in T as measured by T improves with T. So don't bother this technical definition. Just try to understand that what main important facts here are E, that is experience, with respect to some task T, and performance measure P. So this P increases, okay, when the value of E increases. So as when we increase the experiences or that computer program will be able to give you better performance. So this is the definition as per Tom Mitchell. Now, is this magic? Whether this machine learning is a magic? No. The answer is simple no. This is more like gardening. I hope you all, or at least once, did some work in the gardening, isn't it? So this, look at this figure. So in gardening, what we have? Seeds, nutrients, gardener, and plants, isn't it? So if we compare this with machine learning, these seeds can be considered as algorithm. Nutrients are the data, and gardener is of course you, and plants are the programs. Okay, so this means what? You know, from the seeds only we can we may have some plants, isn't it? So seeds plays the vital role. So that's the same way algorithms play the vital role in machine learning. And you need to provide some nutrients, and in this case, data are the nutrients. Clear? And plans are the programs. What you will have as an output is, in this case, programs. So that's the way we can relate this machine learning with gardening. Clear? Now, we should understand the difference between traditional programming and machine learning. And this image, this figure, clearly depicts that fact. In the first case, you see this is the traditional programming, the traditional way of programming. What you are doing here, you have data, you input that data to the program, and you'll get some output accordingly. Isn't it? So that is the traditional way of programming. Now, what is the difference in the case of machine learning? The difference is that, as I have already told you, that what matters actually in case of machine learning is the algorithm and the data and the past experiences. And the past experiences can be thought of as some output. So in case of machine learning, what you are providing data and output, and as a result, you will have some programs which will be able to predict some new facts, some new observation with respect to some new data. So that's the difference between traditional programming and machine learning. Clear? So guys, obviously use the chat option because otherwise I'll think that I'm talking to myself. Okay. So if I ask you that whether you have got the topic, say yes, otherwise no. Okay. Then let's try to discuss some facts about the history of machine learning. This picture clearly tell you about the actually timeline of how this AI, ML, deep learning being evolving. So in the last session, you already got that in 1955, John McCarthy coined this term artificial intelligence. So I hope I have already answered my first question, that who is the father of artificial intelligence? So he is none other than John McCarthy. In 1955, he has coined this term, but in 1956, actually it got popularity. Then in that way, in 1980 onwards, actually, this machine learning field got popularity. And after that, nowadays, 2010 onwards, actually, deep learning becoming a very, interesting area with a lot of problem solving capabilities with an efficient way, more efficient way you can. Okay, so that's how the timeline comes into play. Clear? Now let's have some discussion about the relation, or the relation between machine learning, AI, and the deep learning. So you can consider, as I have already told you, that AI as the superset, where we try to develop any technique that enables computers to mimic human intelligence using logic, if-then rules, decision trees, and machine learning also, including deep learning. So this is AI. The main aim is to make computers to mimic our human intelligence. Clear? So then machine learning is a subset of AI that includes what? Some statistical techniques that enable machines to improve at tasks with experience. And this also includes deep learning. Obviously, guys, when you have some knowledge, basic knowledge and mathematics and statistics, then only you can, I think, go for doing some research work on machine learning. But of course, if your aim is to just apply the machine learning technique, you don't need to bother that. You can easily apply them. Okay. Then deep learning, as I have already told you in my last session, that this is a bunch of neural networks, and extensively used in the different areas, especially in computer vision, speech recognition, like that. So from this figure, what you have got, that deep learning is a subset of machine learning, and machine learning is a subset of AI. So ultimately, all these domains come under one single domain, that is our artificial intelligence. Clear? Now, how does this machine learning works? Look at this figure carefully. See, what we are inputting here, our past data. And this is the training phase. Don't worry, I will discuss training phase after some slides. Okay, so training phase, we are inputting some past data to our machine learning algorithms. And these algorithms will try to learn from the data, and thereby it will build some logical models. So this logical model is being developed from the trained data, and when we provide some new data, obviously they are going to be your test data, then you will get some. So what important means terminologies concerned in this case are training phase and testing phase. So I'm going to discuss them now. So first, I'm considering the training phase. As you have already seen that this is the first phase. So let's you consider an example. You have taken, or you take a randomly selected specimen of mangoes from the market. And why I'm giving the example of mangoes, because you all know that in this means in current days, in this session, obviously this is a session for mangoes. Okay, mangoes can be considered as the king of fruit, isn't it? So that's why I have considered this example. So you take a randomly selected specimen of mangoes from the market, that is your training data, then make a table of all the physical characteristics of each mango, like color, size, shape, growth in which part of the country, and this matters a lot. Use your common sense, because the mango grown in some part of Bihar maybe tastes differently with respect to the mango that grown in some part of Andhra Pradesh, isn't it? Sold by which vendor, that is all, that also matters. Okay, so you can consider them as the futures. Now, along with the sweetness, juiciness, ripeness of that mango, they can be your output variables. So you feed this data to the machine learning algorithm, and it learns a model of the correlation between an average mango's physical characteristics with respect to its quality. So you are building a model by inputting this training data. So that is, this phase is known as the training phase, the first phase. Clear? Now, next time, obviously, what you are going to do when you go for shopping, you will measure the characteristics of the mangoes which you are purchasing. That will be your taste data, and feed it to the machine learning algorithm. And it will use the model which was computed earlier to predict if the mangoes are sweet, ripe, or juicy. Got it? So this phase, as you have bought some new mangoes, they become your taste data, and you are feeding to the already developed the machine learning algorithm, and it will just predict that whether those mangoes will be sweet, ripe, or juicy. So as we are trying to taste some new data, so this phase is known as testing phase. Clear? So you can make your algorithm improve over time, so that it will improve its accuracy as it gets trained on more and more training data set. To mine it, obviously we need more training data set or more training data to make our algorithm more efficient. So thus, I'm not including this fact here, but let me tell you, if 100% data you have, then obviously try to make 70% of those data as the trained data and 30% as the test data. Clear? So these are the two phases, training phase and the testing phase. I hope this concept is clear to you now. You may say yes or no. Well, then I'm coming to one simple question just to check you whether you are attending the session seriously or not. So my question is that whether machine learning is a subset of artificial intelligence. You have been provided two options, yes, option A, and option B, no. You may type option A if your answer is A, or you may type B if your option is. So please quickly type your answer. Don't worry. We are just means is to be very more friendly in this session. So that's why I'm asking this question. Well, I have got almost all the answers as correct. Obviously correct, because the answer will be A. That is yes. So machine learning is a subset of artificial intelligence. This means that you guys are seriously attending this session. Thank you. So let's move ahead. So I now come to the classification of machine learning, and this is a very important topic. So mainly, classification of machine learning means we divide this machine learning into three different types. First one is supervised learning, second one is unsupervised learning, and the third one is reinforcement learning. So then let's talk about each of them. So first, coming to our supervised machine learning. So supervised learning is the type of machine learning in which machines are trained using well-leveled training data, and on the basis of that data, machines predict the output. Guys, you see that I'm keeping some text in red color, or sometimes I put it in bold. That's my way of giving more focus to some particular phrase of that statement. So in this case of supervised machine learning, what matters, what is important is the level training data. Okay, and from that level training data, it predicts some output. Clear? So this level data means some input data is already tagged with the correct output. Don't worry, I'll give some examples so that you'll grasp this topic, this concept. You know, this supervised learning, machine learning, is similar to a machine student scenario. Okay, so you know, a teacher guides students to learn from books and other materials, and the student is then tested for exam, and if correct, the student passes. Else, the teacher tunes the student and makes the student learn from the mistakes that he or she had made in the past. And this is the basic principle of supervised learning. Because you tell me, if you do some programming till now, you know that the best way of learning programming is to learn from your mistake, from your errors. Whenever you got some error, you'll give more focus on that error and you'll try to debug that. And next time you will understand that did these errors come? Or yeah, you need to modify the program structure like that. So that's the principle of supervised learning also. So it obviously tries to learn from its mistakes. Okay, so let me give you one more real-time example. Say you have a niece who has just turned 2 years old and is just trying to speak, is learning to speak. Now, you want to teach her what a dog and cat is. Okay, so you know from this figure, I hope you all can recognize that this is dog, isn't it? Is this cat? No, no. So this is a dog and they are cats. We know that because from our childhood, from our born that we have been taught like that, isn't it? So now, how will you teach your niece to recognize them? There are two ways. Either you show her the videos of dogs and cats. Second way, you will bring a dog and a cat and show them to her in real life, the features of cat, the dog, and so that she can understand how they are different. Is this the way? Of course, this is the way to teach your niece, which is just 2 years old. So this is the example of supervised learning. Because you are teaching your niece, you act as a supervisor, isn't it? So if she is able to differentiate between the dog and cat, so this means you have successfully taught her. So you acted as the supervisor and your niece acted as the algorithm that had to learn, making sure that she was actually learning the correct thing. So this is the principle. Now, how you define the supervised learning in mathematics, in the mathematical definition of supervised learning? So supervised learning is the one where you have some input variables to mine it, and don't forget to ask me if any confusion occurs. So supervised learning is the one where you have some input variables and an output variables, and you use an algorithm to learn the mapping function from the output, from input to the output. I hope you all know function or mapping. In this case, input variables are x, and you try to predict some output variables with the help of some map. So it can be framed as y is equal to fx. Clear? So the goal is to approximate the mapping function so well that whenever you get some new input data, that is x, the machine can easily predict that output variable y for that data. Clear? So in the while you are learning machine learning in depth, you'll get some examples in some algorithm like linear regression, logistic regression, and there you'll play with this type of equations. But don't bother it now because in next times or in future, if I'll give a talk, then I'll discuss that. Okay. So basically now focus that this is the equation y is equal to fx that plays the role in the case of supervised learning. Now, through a figure, I always try to take the help of some figure to depict my concept. Okay, so this is the figure how supervised learning works. You see, these are the level data. Level data is concept is similar, very clear. You know, this is hexagon, so there is a tag like hexagon. This is square, so there is a tag like square. This is triangle, this is a tag like triangle. So these are the labels for this level data. And you will feed them to the model that is being trained. Okay, so the model is being trained through an algorithm. Now is the time to check its performance. So you will provide some new test data. So these are the test data. See, no tagging is here. Okay, test data is totally new. And if the model successfully predicts that this particular structure is square and this particular structure is triangle, then we can say that our algorithm, our supervised learning model is able to predict the correct outcome. Is this clear? I hope this is clear to you. So then let's move ahead. Now, if I talk about main types of supervised learning, then we have two types, regression and classification. Believe me, this is the mostly asked question in the interview or in different semester exam also. What is the difference between regression and classification? Although I am not going to discuss in details, I am keeping it as a homework. You can directly ask me or mail me if you want more example in this fact. Just let me tell you the difference in short. You can consider this regression analysis is a statistical method to model the relationship between a dependent variable, that is the target variable, and independent, that is the predictor variable. Dependent variable is the one which is obviously depending on some predictor variable with one or more independent variables. Now, to understand how the value of the dependent variable is changing corresponding to an independent variable when other independent variables are held fixed. Okay, this is the way of finding out some prediction, and this prediction value will be real or continuous values. Real, by the term real and continuous values, means you'll get the output like 1, 2, 3, 4, like that. Okay, such as more famous examples are the temperature prediction, as salary, price, sale prediction. This comes under regression. So output will be some kind of real or continuous values. While in the case of classification, what happens? It's also try to identify the category of new observation on the basis of the training data. But in this case, you'll get output like yes or no, 0 or 1, spam email or not spam, cat or dog, like that. Clear? So basically, this is the difference between the regression and classification. I hope this is clear to you. Now coming to the next part, that is the unsupervised machine learning. Obviously, this is just the opposite case of supervised learning. Here, what happens? We have unlabeled data set. Okay, so unlabeled data set means you don't have any knowledge about the data set. So the goal of the unsupervised learning is to find the underlying structure of the data set, group the data according to some similarities, and represent the data set in a compressed manner. Guys, please mute yourself. You can use the set option. Okay. So what happens? Mathematically, unsupervised learning means where you only have some input data and no corresponding output. Okay, so what happens in this category of machine learning? Algorithms are left on their own to discover and return the interesting structure in the data. Okay, so let's try to understand through a figure. So this is the input raw data. You'll see these are the different objects of cat and dog, of course, and they are unlabeled. Please mute yourself because or who is okay. Please mute yourself. So these are the input raw data, and they will be fed to our unsupervised learning model. So they will be interpreted and they will be tried to group on the basis of some homogeneity criteria or some similarities. And when this will be processed, we'll get the output like this. So there are two groups One group contains dogs and other group contains cats. So how exactly this thing is carried out? Although this is, these are unlabeled data, so we use the some similarity criteria or some homogeneity criteria to match them or to form separate groups out of them. Clear? That's how unsupervised learning works. And if I speak about the different types of unsupervised learning, we basically have two types. One is clustering and another is association. Clustering can be defined like a method of grouping the objects into clusters. Guys, cluster means just group. Okay. So such that objects with most similarities remain into one group and has less or no similarities with the objects of another group. It means to say that you are just trying to partition your data set into different groups so that the objects belongs to one group, say group 1, will possess high similarities among them, and the objects will be possessing different means behaviors or properties to the objects of another group. Clear? Because Goli Saha, please mute yourself. Okay, otherwise it may disturb others. Okay, please do it. So that is the definition of clustering. We try to divide our data set into different groups. Now, what is association? Association, again, a kind of unsupervised learning method. And this is used for finding the relationship between variables in a large database. And actually, it tries to determine the set of items that occur together in the dataset. Let me give you one real-time example. In a shop, when you go for purchasing 1 liter of milk, then there is a high probability that you will also purchase dozens of egg, or you may purchase one bread, isn't it? So these items means milk and these eggs, they occurs together, or milk with bread, they occur together. So what happens when that shop means in that shop, if that shopkeeper is means giving some what I can say, if he is keeping some bread in front of you when you are purchasing the milk, then there is a greater opportunity for that shopkeeper that he will get extra means selling for that bread also, because that person might be going to buy that bread when he is buying the milk, isn't it? So this is a kind of typical example of association rule, and this idea, believe me, is being well utilized by different e-market means Amazon, Flipkart. They are employing this concept, and this is known as market basket analysis in the case. I hope this concept association is clear and clustering is also clear to you. So they are our unsupervised learning. Yes or no? So I suppose this is clear. So I'm now coming to the next type, that is known as reinforcement learning. And this reinforcement learning is also known as feedback-based machine learning. You just remind, in the last session of my artificial intelligence, I show you an application of AI as the its application in game playing techniques. And one famous example I have cited is the fear game, FEAR, isn't it? So what happens in that game, opponents try to learn from you, okay, from your strategy. And each time that games become harder and harder and more challenging. So that is also a kind of feedback-based machine learning. So what happens here, as this is a kind of, application of AI, so two important terminologies plays major role here, that is agent and another term is environment. I hope you all know that. If you don't know, please don't worry. Means after this session, I'll give some link of my lecture that I am discussing about this agent and environment in details. So what happened? An agent learns to behave in an environment by performing the actions and seeing the results of the action. So for every good action, the agent gets positive feedback, and for each bad action, the agent gets negative feedback or penalty. So this is a kind of machine learning method where an intelligent agent, that is computer program, interacts with the environment and learns to act within that. Clear? So examples I have already cited: the game playing technique, where the opponent tries to learn from you. Okay. Then robotics also, and one famous other example is the self-driving car. The self-driving car also, we are using this reinforcement learning. Clear? Now, one question to you, as I have discussed this different types of machine learning. So please tell me, okay, whether regression is an unsupervised learning or not. Option A, yes. Option B, no. So please respond for your search option. Okay, so respond it quickly. I'll pause for 10 seconds. Please, guys, I'm giving you these questions to make this session interesting only. So please respond from the options, either A or B. Please watch these questions very carefully. Regression is an unsupervised learning. Is this clear, correct or no? Option A says yes, option B says no. So please see the question first, then reply. Answer is yes, A. Might be you forgetting that while I am discussing about the types of supervised learning, I told you that two important types are there: regression and classification. So obviously answer will be B. No, regression is not an unsupervised learning. Regression is supervised learning, guys. Please, the answer will be A. Clear? Any doubt? Can I proceed? Okay, I can consider this as move. Okay, please. So regression is a kind of supervised learning. The answer is option B. Now, I'm coming to the life cycle of machine learning. That is machine learning life cycle. So you'll see 7 steps while developing this machine learning model and employing them. The first option is the gathering data, first stage, sorry. In the first stage, gathering data. Second stage, data preparation. Third stage, data wrangling, and this is the most important part. This means when you give correct data, so there is a more, means the probability of getting accuracy, more accuracy will be increased, isn't it? The data wrangling means how you actually, you are scaling the data, how actually transforming data into the correct format, removing the outliers, then the analyzing the data, then training the model, then testing the model, and finally we have deployment of the model. So overall, these stages constitute one machine learning lifecycle. So you can take a screenshot if you think this is important for you. Clear? Now, if you want some data sets to do your experiments, your machine learning algorithms, means you try to employ them on some standard data set, then I'm citing 3 important sources. First one is the Kaggle dataset, and this is the link. Second one, which I frequently use, the first 2 I frequently use. The second one is the UCI machine learning repository, and this is the link for that. And the third one, also becoming popular nowadays, that is dataset via AWS, and this is the link for that. And these links I will provide after the session, so don't worry about it. From these links, you can easily download some CSV files, some datasets, and you can work on that. Clear? Now, finally, I come to the applications of machine learning. Although there are several other applications, I'm trying to just cite some important. From this figure, see, this figure depicts what? Automatic identification or detection, image detection, isn't it? Then, this is the self-driving car, and this is what customers who bought this item also bought. And this is what your emergent virtual assistant, isn't it? So all these are some applications of machine learning. So first, I'm discussing the social media application of machine learning in social media. I'm considering the more popular one, that is the Facebook. And no need to say, whenever you are trying to upload a pics of you along with some friends into the Facebook, then you'll have some automatic friend tagging suggestion from the Facebook, isn't it? So what happens? Facebook uses face detection and image recognition to automatically find the face of the person which matches his database and hence suggests us to tag that person based on that deep face. You may know this term deep face. Actually, this deep face is the Facebook's deep learning project, and this is what actually responsible for the recognition of the faces and identifying the persons behind that picture. Means you suppose you are some four-person and three of friends are already there in the Facebook. You don't need to type the names there. Facebook will automatically suggest. Okay. So one notification that this meeting is going to end in 5 minutes. I'll provide you a new link. You may join after that. Okay. So this is one application of machine learning in social media, that is Facebook automatic friend tagging suggestion. Maybe you will get alternative tag option there. Okay, so then next one is the video surveillance. Here, what happens? Consider a scenario when a single person monitoring multiple video cameras. Certainly, it is very difficult job to do and also boring as well. How many actually different, screens you are going to monitor? So obviously, this is a kind of boring task also. And here, why the idea of training computers do the job makes sense. Here. So the video surveillance systems nowadays are powered by AI that makes it possible to detect some crime before they happen. They track some unusual behavior of people like, standing motionless for a long time, stumbling or napping on benches. These different behaviors a normal person is not going to do. Okay, so this will recognize that those are the persons who are actually maybe going to do some crime. So this system can thus give an alert to the human attendants, which can ultimately help to avoid some missteps. And when such activities are reported and counted to be true, they help to improve the surveillance services. And this happens with machine learning doing its job at the bank. Okay. Clear? So in case of video surveillance also, we are using actually machine learning tools. Then in traffic alerts, I know that maximum of you already use this feature, that is a Google Map. This figure, that is the Google Map. And this is the app which we use whenever we go out and require some assistance in direction and traffic. Suppose you don't know a place, so then you will just give the destination name and you will follow the map, isn't it? Then other way, when I was traveling to some another city, then took the expressway and then maps will automatically suggest you, despite the heavy traffic, you are on the fastest road. But actually, how does it know that? Obviously, from your data. It's a combination of people currently using the service, some historic data of the route that collected over time, and few tricks acquired from some other company. Everyone using this map, providing their location, their speed, their route in which they are traveling. That obviously people try to choose the shortest route. Okay, and from this data, actually Google is maintaining a kind of massive data sets about the traffic, and this makes them predict about the upcoming traffic and adjust your route according to it. Clear? So this is a well-known application of machine learning in traffic management. Then next one is the product recommendation, and this one is also very famous. I already given this example. You just second item on Amazon, but you leave it. You don't buy it then. But next day, when you are watching some videos on the YouTube, or you will see that ad appearing before you for the same item, might be giving some discount also. Similarly, you switch to Facebook, again seeing the same ad, isn't it? So how that happen? You view this product, customer who viewed this also viewed. So how this actually happen? Well, this happens because Google tracks your search history and recommends ads based on your search history. So Google search option you cannot consider is as a secured one. Okay. So this is one of the coolest application of machine learning. And in fact, 35% of the Amazon's revenue is generated by from product recommendations. So this is one important application of ML in product recommendation. Then the next one is the virtual personal assistant. I don't need to say more about this because I know that you all know about it. And as the name suggests, virtual personal assistants assist in finding some useful information when asked via text or voice. Okay, then what are the applications of machine learning we are using here are the speech recognition, speech to text conversion, natural language processing, text to speech conversion, and these